Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to talk about dot product of parallel vectors and how do we go about it. Please don't forget to like, share, and subscribe. And if you've not clicked the notification bell, I don't know what you're waiting for. Please do that so that when I post new videos, you'll be the first person to know. All right, so quickly, we've talked about parallel vectors in the previous video. I've shown you also how to find parallel vectors, but now we're going to do the find dot product of parallel vectors. So basically, the dot product of any two parallel vectors is just the product of their magnitude. So remember, I told you that the angle between parallel vectors is 0. And since we know that dot product A dot B is equal to the magnitude of A, magnitude of B cos theta, and we know that parallel vectors theta is equal to 0, right? So that means it's going to be A dot B is equal to the magnitude of A, magnitude of B cos 0. And we know cos 0, this is equal to 1. All right, we talked about this in trigonometry. So therefore, we can now say A dot B for parallel vectors is just the product of what? The magnitude, all right? So because I'm aware that students do take notes, I'm going to write down what I just said. We'll just pick maybe one or two examples, and we're going to go to the next one, which would be like the vector product of parallel vectors, okay? All right, so let's get cracking. So the first thing here, we're going to start. So I said the dot product okay, the dot product of any two parallel vector okay, the dot product is just the product of their magnitude. Okay, because the angle between them is 0. Between the two vectors is 0, okay? So we have A dot B is going to be equal to the magnitude of A, the magnitude of B cos theta, okay? Like I said, we talked about this when we talked about the dot product, but we know that in this case for parallel vector, theta is equal to 0, right? For parallel vectors, we are aware of that. When I was talking about parallel vectors during the when I was talking about the overview of parallel vectors, I also mentioned that there is no angle between two parallel vectors, okay? So when we know that, we can now say A dot B is going to be equal to the magnitude of A, the magnitude of B cos 0, but we know that cos 0 is equal to what? 1. We talked about this in trigonometry. So therefore, A dot B is going to be the magnitude of A multiplied by the magnitude of what? B. Okay, or you can just say A dot B is equal to the magnitude of A, the magnitude of B. So if you want to write it like this, so it's the same thing. All right, and that is that. Okay, so let's pick some examples here. Let's pick up some examples. So number one, I have here. So we're told that vector A given by 3i minus 2j and vector B given by 6i minus 4j are what? Are parallel vectors. So now we're told they are parallel vectors, all right? We're now told to now what? Find the dot product. So that means we now know that A dot B is going to be, because they are parallel, it's going to be the magnitude of A multiplied by the magnitude of what? B. So the first thing we have to do is to find the magnitude of A. So I've talked about magnitude earlier. So before we do that, we can now rewrite A. So I always like writing A's, my vectors in column form. So A, so it's 3i minus 2j. So that means the x is 3, and this is minus 2. And also we can write the B also in column form. It's going to be what? 6 and minus 4. So now if we're finding the magnitude now of A, is going to be equal to the square root of 3 squared plus minus 2 squared. And that will give us 9 plus 4, and that will give us 13. Then we can also find the magnitude of B, which is going to be square root of 6 squared plus minus 4 squared. So that will be 16 plus 36, and that will give us 2 root 13. All right. So now we can now find A dot B now will be equal to the magnitude of A, which is root 13, multiply by the magnitude of B, which is 2 root 13, and that will give you what? 26. So therefore, we can now say the dot product for these two, A dot B, is going to be equal to what? 26. Okay? And that's how you find the dot product. Let's pick just one more example for this, okay? Then we'll go to the next topic. So let's assume we're told to find the dot product of two parallel vectors given below. So we have A is equal to 4, 3, minus 2. And we have B is equal to 12, 9, minus 6. Okay? And we're told to look for the dot product. So it's going to be A dot B is going to be the magnitude of A multiplied by the magnitude of what? B. So we need to find the magnitude of A. The magnitude of A is going to be equal to the square root of 4 squared plus 3 squared plus minus 2 squared. Okay? And that will give us square root of what? 29, because this is 16. 16 plus 9, that will give you, this is 9. 9 plus 4 is going to be 13. 13 plus 16 will give you 29. Then we can also find the magnitude of B. Similarly, we're going to be square root of what? 12 squared plus 9 squared plus minus 6 squared. And that is going to give us 3 root 29. Okay? So now we can now find A dot B. A dot B is going to be equal to the magnitude of A, which is square root of 29, multiplied by the magnitude of B, which is 3 root what? 29. And that will give us 29 times 3, and that will give you 87. So therefore, we can say A dot B for this question is equal to what? 87. And that is how you find the dot product for two parallel vectors. All right, and that will bring me to the end for this video. The next one I'm going to talk about is the cross product of parallel vectors. So that's why it's important for you to subscribe and click the notification bell. So when I post the next video on cross product of parallel vectors, you'll be the first person to know. So if you have any question and if you're confused, please don't hesitate to contact me. All right, send me an email and I'll get back to you as soon as I can. All right, so see you soon. I'll see you in the next video.